Congrats on making it to the final exam era week. This is going to be a mega mix where I'm going to do my best to hit all of these review sections that have been handed over to you. You can most likely find blank versions of these on Blackboard. I might not talk through a bunch of these. I might just complete them because you should kind of know what you're doing at this point. So, what are we doing? This isn't right, is it? It's -6. The key thing with this problem is noticing that, yeah, this is 1 over 32, and you might think, ew, icky sauce. I wish it was just positive 32, not a fraction. But you could always just recall that 2 to the 5th should equal 32. So that's why I rewrote this as 2 to the -5th power. That's a safe move. Your answer here is -6. You can even plug in and check your work if you do so desire. You could take a square root to break this thing out of jail, getting you plus or minus 5, because the square root of 25 is 5. And then if you keep this going, you could add 2 to this. So it's 2 plus or minus 5, and all that's divided by 3. So you have two answers here. One of them will be 7/3, and then the 2 minus 5 will be -3 over 3. So your X solution set is 7/3 with -1. So notice you have two answers there. This is light work. You could have done this back in integrated 2. Factors of -10 that add up to 3. Probably going to be 5 and -2. And keep in mind, this is set equal to 0. So at this point, you can kind of think of it like you're solving for the roots. So your answers are -5, 2. And you may see me do these curly brackets, and that's because I'm talking about a set. I had a lot of peeps ask me about this in class, so I feel obligated to complete it. You might notice that this is 3, 9, 27. What do you think they all have in common? They could all be rewritten as base trace. This is a safe move, what I'm doing right here. 3 to the 3rd is 27, 3 squared is 9. So now ask yourself, aren't these all the same base of 3 now? Where you could combine these two and say that it's 3 to the x plus 2 power. And then how would you break this further? Break it further, yeah. Further make it unusable. Multiply. So you end up getting the same base, which is a good thing because now you can just solve this. And I'll leave it to you to solve that. Hope that makes sense. Light work, not even going to do it. We have term up top and the bottom. So just deduct the bottom. I think some people would get into this and like want to rewrite it as like a fraction divided by a fraction, but no matter what, top subtracting the bottom is a safe move, getting you q to the 4th. How is this different? F inverse of -9 saying, well, if your output was -9, what was the input? It's got to be 2 based off of this. How is this different? Well, we know that f of -9 is 6, and this is really just 6 to the -1 power, which is 1 over 6. Notice how that doesn't equal this 2. That's different things. This f inverse of f of 2, well, we know f of 2 is -9. F inverse of -9, what we did back here, it's just 2. This ends up as just pi, because this, like, when you have your inverse composed inside of a function, it's just this output, or I guess in this case, the input. This is light, just switch all the numbers. Yada, 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 do all that. Hopefully you look closely at this and you say that this is losing 5, losing 3, losing 1. Hopefully you then take this further and say, oh, looks like it's going to be a quadratic. And if you really look closely, it's going to be x squared. This problem I kind of have an issue with, and you'll see maybe in a second. You could assume that the domain continues in that direction. So it's this, the range goes from 0 to infinity, because if you think of x squared, that's how that operates. And then the inverse of it is square root of x. But this is, I don't know, kind of conflicting, because I'm claiming that the domain is 0 to infinity. But I guess that does kind of work, yeah. But then the range doesn't quite match up, because it's claiming that it would be from negative infinity to infinity, but it's like kind of not. So interestingly, and this problem, like, I don't know, this stuff's kind of weird to think about. So I'm just gonna move along, act like it never happened. You saw in 1.3 that exponentials are chill and they have an inverse where it's just the log to that base. So just switch the points around. Can't really do too much with this. Kind of goes like that. Did my best log 2 of x. There you go. This is one to think about. This is definitely in unit 1 and kind of goes over some people's heads. This graphed out would be a vertex form equation that looks like that. And this is interesting because if we were to flip this, it would produce some graph like that, which is no good because we don't really want to use this as our inverse function because this isn't a function. It doesn't pass the vertical line test. So what you want to do is either talk about this half, the right half. I sound like cousin Craig from Succession if you're watching that from the left. So you want to do that as an option to talk about the right half, or you could go at it from the way left, and that would just be this portion, not the right, all the way up to -2. Notice this is for the x coordinate, not the y coordinate. Notice how it's opposites for this. We'll do a quick inverse. So pretty much switch these variables. You have x now equals y plus dose squared minus 3, and then just solve for y. So add 3. Take a square root. And you now get square root of x plus 3. Then deduct the 2, and this now equals g inverse of x. Luckily, nothing in this case was already labeled y, so this is kind of a safe move. So square root of x plus 3 and then -2 after that. And we'll do a quick graph of this. I'm trying to speed run this, as the gamers say. So what's this? Left 2, down 3. Left 2, down 3. It's that. 1, 3. So this is the normal g of x. We know that this domain is definitely going to be from where to where? Well, from -2 to infinity. And so that means that our range for the inverse is going to have to be -2 to infinity. And so you could also tie in the fact that this range should be from -3 to infinity. And that also helps us graph this because we know that we need it to go from -3 to infinity. So -3, it's going to be way left. Range starts at -2. And then you do your best to kind of curve this. And then you can still kind of follow through with the 1, 3 over 1 over 5 up 1 kind of ordeal. So this is g inverse of x. And again, notice that we didn't have to double down and like show the bottom portion of it, because then that wouldn't be good. Then it wouldn't be a function. In this case, we're good. kind of a cool problem. These are details you should definitely recall because that'll definitely help you graph this out. There you go. Cool problem. Find the inverse. You already did problems like this. This is what? I'm at the point where I don't even have to like write it out stepwise because I've just done these so many times. What's this? X to the fourth minus 1, all that's divided by 2. That's the inverse of x. Again, key thing is switch x and f of x. Solve for the one variable. You could also impose them, and if they produce the same outcome of x, then you're in good shape. F of g of x. Yeah, I'll do one of these. That's fine. You know f is this, so it's 2 over. Instead of x, you're putting the whole thing of g of x. This is pivotal. Plus 3. And this actually isn't too bad because you can see pretty quickly that theories will cancel. And now you're trying to simplify 2 over x. This is division of fractions. The top you can rewrite as just 2 over 1. Flip the bottom. Just gets you x. And if all goes according to plan, this should also equal x, but I'll leave that to you. Unit 1, done. Cool. Unit 2, how are you? Logs, we're back to the 4th power. Definitely equals 16. So this should be equal to 4. We saw in the previous unit that even though this is not as desirable as having log base 3 of 9, well, hopefully you look at this and you say, yeah, this would be 2. And since this is just a fraction with 1 up top, just say it's -2. This, you're now dipping back into the square root of 16. So 16 to the 1/2 power is 4. Yada, yada, yada. Recall that this is always base 10. So 10 squared equals 100. This is definitely going to be some negative number that I will leave it to you. Recall that ln is really just log with base e. And so since the base matches the argument's base, just say your answer is the exponent, which is 6. Leave those other ones to you. This one, kind of cool. Could just guess and check. But you could also just go to this exponential form. This is key thing here. And then how would you get rid of the 4? Hopefully you're saying you do a, guessed it, quartic root, saying that the quartic root of 81 is just going to be 3. And positive 3 in particular, don't get it twisted because you can't have a base that's negative. Hope that makes sense. Base matches the argument, so it's 1. Fraction, just -1. 2 to the 0 power is 1. This is like, this is a big one. It's the exponent rule, power rule, what have you. You can move this 9 to the front and say that it's really 9 log base x of x. Base matches the argument base, so it should just be 9 times 1. So this is just 9. You heard me? Makes sense? These are kind of cool. I like these problems because you can't just, I mean, you can go with things you know, like if the argument's 1, that outcome is 0. 4 to the 3rd power is 64. Base matches argument, so that's 1. This is going to be some negative number because this is less than 1, so it's got to be some negative number. Try it if you're not convinced. And then you can kind of compare this one with this one. I think this is just good test taking strategy. Notice that these share the same base, but this argument's a lot bigger than 64. So this is just going to be some number that's greater than 3. And previously 3 was the head honcho. So from least to greatest, C is definitely a negative number. So that's done. 0 is the next best. Moving on up. We're hitting B because that's 1. E because it's 3. A because it's some big number that's greater than 3. And that's the game. putting it in least to greatest. I like those problems. If you don't recall your properties of logs, you're going to have a tough time here. So please recall that if you can rewrite the argument as a product, you can then separate them into their own logs using what operation? What would you use? Hopefully you're banging on your keyboard saying use addition. So just saying that in this case, it's A plus B. I like these problems because you can't just use your phone and take a snapshot of it and figure it out. You have to actually dig in and like think strategically on it. I'm sure you can take a photo of these, but you're much better than that. You worked very hard this year. So hopefully you keep those momentums going. This is log base 5 of 5, that's just 1, and then deduct log base 5 of 3, which is B, so 1 minus B. Capiche? Sound good? This one's kind of cool. You might approach it same way as before. This is quotient rule again. And then you get to here, and you're like, well, I don't really know where 9 is going to take me. Well, isn't that just 3 squared? Can you then use exponent rule to rewrite it? We know log base 5 of 4 is A, and then just deduct 2 versions of log base 5 of 3, which is just B. So A minus 2B. Capiche? Makes sense? Pushing this all to 1 log. Exponent rule to me is screaming that it needs to be done here. So cube all of this. You'll then deduct log base 2 of 4x. And you might think like, oh, I should rewrite this, but the goal is you want to keep it to 1 log. So it would just complicate things if you separated it. 5x cubed is 125x cubed. Divide that by 4x. What can cancel? Hopefully you're saying the x here and here. And this is about as good as it can get. If you can simplify this fraction, let me know. But I don't think it can be done. That's what this is. Bueno. Benissimo. Going now, flipping the direction we're trying to expand these. We got, just for starters, log base of 3 of 81 plus I'm already caching this 3 and how it can be rewritten to the front. So that's a good move to just knock it out. And it's a nice little addition family. Log base 3 of 81, you can simplify that to 4. And that's the key thing here is that if you see numbers where you can most likely simplify the log, take advantage of that, do that. It's a good move. You won't regret it. Quotient rule, we'll kick this one off. And I used to trip up on these problems back in the day. So how I work around it is saying that I'm subtracting literally everything that's in here. And I even use brackets to like enclose it so that I'm recalling that everything in here was subtracted. Even though I'm saying it was addition that brings them together just for a split second. So exponent rule can do that. So 3 log base 2 of x. And you're now deducting, what would this be? 3. And you can also distribute, say that you're deducting log base 2 of z. So the properties, make sure you know them, make sure you recall them, know when to use them. Hope that helps. I really like these problems here. I know it doesn't seem like an enjoyable one to like, but I'm hoping at this point in the game, you can just do a quick sketch of 4 to the x and say, all right, well, y-intercept is just 1. It hits 1, 4. And then log 4 of x, that's just the inverse of it. So let's break this one down. This is just a super quick sketch. what's true. Both functions are definitely increasing. This goes up to the right. This takes its time going up and to the right, but it gets there. G of x has a horizontal asymptote. It definitely doesn't. That's false. That being said, it has a vertical asymptote. F of x has a vertical asymptote. That's false. Might be nice to pop in and say, no, it's actually vertical. This is actually horizontal. The range is the same. Well, let's decide on that, because this range for f of x is 0 to infinity. And this domain for g of x is definitely 0 to infinity, not including. So this is actually true, interestingly enough. Hope you know the check marks mean it's true. E, I'll tell you right now, it's false, because they try to throw in this log base 4 of 1 over 16, claiming that that sends it up 2 units. But in reality, that would send it down 2 units. If you're not convinced, try graphing it. Let's pop to this. Yeah, why not? Let's graph this out. This is log base 2, but you're shifting to the right 2 units and you're going up 1 unit. It might be nice to just sketch out some log base 2 effects points. It's not a bad idea at all, because if you have these down, you can then just kind of push them accordingly. If this was, what would it be? -2? No, sorry. Let's do 1/2. Then this would have to be -1. I hope I'm getting this right. If it's to log base 2 of 1, that's to the 0 power. We'll do some more. 2 goes to 1, 4 goes to 2. So then this is saying really just move all of these x coordinates to the right 2 units and then go up 1 for f of x. So this would be 1/2 plus 2 to get 2.5. Add 1 to this, so it's 0. Go right 2. So this is 3, 1, 4, 2, 4 plus 2 gets you 6. 2 plus 1 gets you 3. Those should all be good. I'll leave it up to you to graph it. You'll definitely have a vertical asymptote where x is 2. Hopefully you know that. And it kind of shifts the x-axis up too. I don't really consider this an asymptote, but some people do sketch it in just to show that there is a vertical shift upwards. Don't be afraid to do that if you are so inclined. And, it does something like that. I know I said I wasn't going to graph it, but that's a quick sketch. Just 3 points. Hope that works. You go into log form for these. This is already an exponential form, so send it back. Claiming now that x plus 2 equals log 4, 200. So then x equals log 4 of 200 minus 2. I posted a video a bit ago on how to evaluate this with any old calculator. Quick summary of that video is that you can do log 200 over log 4, then just deduct 2, and that'll give you some approximation. I hope you go do that, since this asks for the decimal approximation. I'll leave that to you. You're solving for e of x here, roughly. I mean, you know you're solving for x, but, come on. Get rid of the 3. So now it's equal to 10. Divide by 2. You're now in a good spot because you have e to some power equals 5. So go to ln form. 3x now equals ln of 5. Divide by 3. This is now what x equals. Boom. Wordiness. I guess I should create one of these equations. You have a percentage that's given to you. Immediately, you should put that in as a decimal wherever they're talking about rate. That's pivotal, and that's honestly where I see people trip up the most. You are showing that 42 people have the virus and it's aiming to triple. How long will that take? So you could set up growth because you have a principal of 42. Your rate's 0.015. You don't know the time because it's asking how long will it take. And you're aiming to get 3 versions of 42. So solve it. I mean, you've done these, right? Divide 42, 42. Now have this. This equals 3. Go to ln form. 0.015t equals ln of 3. Then simple division. Divide by 0.015. And then get what this is going to be. That'll give you the amount of years, I believe. What's it doing? Years? Amount of time? I don't think it gives a, yeah. So just assume it's amount of years. See you in unit 3. Welcome to unit 3. This is a fun little power mix we're going through, power hour. Hope you are enjoying this power hour or power half hour, however long this goes until I have to go do something else. This is light work with the arithmetic. Key thing is if you're subtracting, don't be afraid to sketch this out. I know I'm at the point where I just kind of know what's what, but you can label it like this. The order does matter. Show that you're subtracting all of this because that's a big deal. So 0 minus 3x squared is just negative 3x squared. 7x minus 5x is 2x. Negative 2 subtracting negative 2. It's just 0. So this is that difference. You'll want to box this one up. You could have f of x up here. 7x minus 2 down here. Go to town, combine like terms. Notice that I'm caring about the signs because the signs do matter. Don't forget them. And then you'll be able to combine these x squared terms and these x terms. And it's just a jolly old time. It's just great. It's awesome. This, you could go brick and mortar and foil this out and get something like, what would it be? 49x squared minus 28x plus 4, and then square that again if you're so inclined, or if you want to use a Pascal triangle. I may do one of those problems in here. I will definitely do the easier of the two compositions. I'm opening up g of x and putting in f of x. Distribute this up. I don't know why I keep saying it's converting the file. If anyone knows how to fix that, let me know. I think I've been pretty patient personally. And then combine your constants. Light work. At least for this one. I don't think this one's too bad. Okay, let's keep going. Factor and get roots. You definitely factor out x. This is then a difference of squares. Your roots are going to be respectively x. Yeah, roots are x. Brilliant. The roots, when you solve for them, you'll have 0 definitely, and also plus or minus 4, because again, this can be taken further. So please do that because it's the difference of squares. I'm just trying to power hour this right now. I don't really have a preference with how you show that x plus 5 is a factor. I'm going to use synthetic division, which I think I've been pretty vocal on how I think it's fair game and can use that approach. But don't be afraid to check your work with long division if need be. And so boom, right here, this is helpful because since our remainder equals 0, that's enough reasoning to now say that x plus 5 is a factor of q of x. So this is one way. I know there's another problem in here where it asks for a second way. And what you could do there is just FOIL out x plus 5 with your checking vocab, the dividend, which would be from right to left, -6, negative x, and then x squared. And you could show that that equals q of x. So if you needed to just fact check, you could check your work that way. This is, well, what's common with everything? Hopefully you're saying it's x. And then you can think factors of 6 times -2, so -12, that add up to 1. So it's definitely 4 and -3. So you can now rewrite this as 6x squared plus 4x minus 3x minus dos. Group it, factor out 2x, leaves you 3x plus 2, factor out -1, leaves you 3x plus 2, and that's a good thing because you want those binomials to match if you're doing factoring by grouping. So then all together now, your GCFs make their own little nice binomial. This is the most factored form. Then if you set each of these equal to 0 and solve, you'll have these roots respectively 0, 1/2, and -2/3. Let's count them 3, which makes sense because it's a degree 3 polynomial. So it just makes sense. You would have 1, 2, 3 roots. Capiche? Caposh? Little PT, not physical therapy, but I guess after doing one of these problems, you might need to do some stretching. Simple Pascal triangle, 0, 1, 2, 3, 4. This problem's really reaching. I don't know if I'll actually complete all of it, but this helps us right here because this is saying that our coefficients for this should be 1. I'll actually sketch out like the A idea because this will be your A term, -1 will be your B term. Start with A to the 5th and then B to the 0, and then add on 5 times A dropped 1, B is added 1, plus 10, A cubed, B squared, 10, A squared, B cubed. Think of this again like a seesaw. Your A term starts out pretty high up, B is pretty low. Then the tables turn, where eventually B should be getting bigger and bigger with its exponent. Maybe it goes more negative, but we'll see a little bit of it. You have 4th and 1, A to the 0, which is really nothing. Why do I write it? Maybe to show that there is the pattern here. And I think I might just leave that for you. Because this will be the first term. Plus 5 versions of 2 to the x to the 4th power times -1 plus 10, 2x cubed, -1 squared, plus 10, 2x squared, -1 cubed. You could also just FOIL this if you really want to, between you and I. Little tip there, but I think these problems are nice because you really want to watch every little detail, and it does kind of train you to problem solve, especially if you make a small blooper somewhere. I'll leave it to you to take this further. Hope that one helped. Again, I'm going to use long division. This is how I would set it up. 1, -2, 4, -6. Drop. These problems are so chill. Then 21 minus 6 is 15. So what's this saying? This is saying that g of 3 is 15. It's called the remainder theorem, which is roughly saying that if you were to plug in the root, so the root, it should equal the remainder. So the root of one of the factors should get you the remainder. You did that. This is x cubed going left 2, up 1. Recall, kind of looks like that. This would do the same thing, but flips it. So now it's up high and then ends low. It's kind of tying in end behavior there. These are cool. I like these ones. You have some roots. One of them is at -1, 1, 2. So one factor you'll definitely need, and this is because you have a root at -1. It's just x plus 1, cuts right through, so there's no need to square it. You hit x as 1, but it hits and bounces, so you do want to square it. And then you want x minus 2, since it just crosses through, just keep it as 1. And I guess you should fact check that it hits the y-intercept or some other point, and if you do, it does kick you back 0, -2. So there's nothing you need to put here. You can just put like a 1. Luckily, it opens upwards, so it seems like we're in good shape. This will probably be the equation. And again, you don't really have to put the exponent of 1 here, but just for style, so you know that I'm acknowledging it on both. Do that. When I look at this, if it's starting in the top left and going bottom right, it's probably going to be some negative cubic function where we see that there's a root at 0 and 3. And at 3, it bounces. So I'm going to say that it hits and bounces. So yeah, I think this is like pretty much it. And again, you don't even really need to write the -1. You could just put a minus sign, but you do want to acknowledge that behavior there. So I hope that makes sense. This looks like a cubic function with a positive coefficient at the front. When x is 0, it looks as if it hits and bounces. So I'm going to say that that's being squared. And at 3, this just cruises right through. It's probably just to the first power. This looks like a pretty standard cubic function. And the y-intercept's definitely 0. So I think we're hitting everything that we need to hit. Yeah, done. And that's unit trace. Oh my gosh, you're still there? This power hour continuing? This is going to be a pretty quick sweep through of unit 4. Going right to up 4, recall 1 over x, looks like this. For the left, looks like that. There's a horizontal asymptote where y 0. There's a vertical asymptote when x equals 0. Some pretty chill points. You should just be able to recall this at a moment's notice. When x is -3, it's -1/3. When x is -2, it's -1/2. -1, -1, 0, it's undefined. +1, +1/2, +1/3. So this, you're going up 1 for sure. It's going to flip, which means that you're going to have it in the top left, bottom right. And also there's a stretch factor of 2. So this one, I think I'm actually going to sketch out. So let's make a very terrible x and y axis. You're shifting up 1 unit, so abide by this horizontal asymptote. You're flipping this, so I kind of think of this as like rise and run. Like since the stretch factor is 2, I know that I'll have to go over 1 and then up 2 to get another point, and then do another variation of that where I go right or over 2 and then up 1 to make that kind of graph. If that makes sense. So stretch factors 2, so I'm going back 2, up 1. Also going over 1, up 2. So I like do a parity on a 1/2 slope and also a 2 slope. So there's that. Do the same thing here, over 2, down 1 from this like fake origin, then over 1, down 2 for that. And luckily, this is just a vertical asymptote of 0. So something like that. Capiche? Notice the flip. This, if you factor it, you can definitely cancel the x plus 2. But that will produce what kind of point? Produces a hole. So that's a big thing to acknowledge that there's going to be a hole at x equals -2. So sketch this like you normally do. Go right for, sketch that vertical asymptote. Go over 1, up 1 from the origin. Maybe do some halves in there too. And then wherever -2 is, just put an open circle. I think it's like what? If you were to evaluate f of -2 for this, you get 1 over -6. So it makes sense. It's like pretty in there. Kind of as if it's on the x-axis, but of course it doesn't actually hit. You already know that. There you go. Key thing, open circle at -2. You can factor out 4. You can factor this. You can cancel, leave that to you. This is difference of squares for the top. Cancel, leave x plus 4 over x plus 1. You need to get common denominators here, so definitely multiply this side, top and bottom, by x minus 2. Multiply this side with x plus 2, because again, these are not the same denominator from the jump. So get something like that, plus 1 version of x plus 2. Your denominator is all this. I wouldn't FOIL the bottom out, because you might be able to cancel something in time. Cancel of time, like a Zelda parody. You can then combine. Bottom, I just get lazy sometimes and I just keep writing the binomial so that I acknowledge that it's still there. Combine your x's, combine the constants. There you go. You already know how to do this, right? You just multiply with the reciprocal of the second one. You can even factor as you rewrite it when you really know what you're doing here. Gonna have a bit of cancellation. X minus 1 also. So final answer in this case, x minus 2. A lot cleared up. Very cool. I don't think, I do think this, there may be some factoring that can be done here and some canceling. I don't think this can be factored though. So there you go. There were a lot of rules that dealt with horizontal, vertical asymptote. Key thing though, the horizontal asymptote had a bunch of rules of like, if the top degree is greater than the bottom degree, what did that imply? Top was greater than bottom, that implied something. If the bottom was less than the top. Oh, yeah. Wait, hold on. Yeah. This would imply that your horizontal asymptotes y equals 0, whereas this would imply that there's none. And if they were equal, then you have to do what I'm doing in this case, because this is x to the first, x to the first. So in this case, it's the ratio of the coefficients, 2 and this 1. So your horizontal asymptote in this case is y equals 2. Vertical, set the denominator equal to 0 and solve for whatever roots or factors are there. So in this case, x is -4. The slant asymptote only occurs if the top it's greater than the bottom. It's the only time it's going to occur. And I do think that these look like the most pleasing when there's a slant asymptote. So maybe go back in your practice and try to find one. What can we do here? Okay, so this can definitely be factored further. X minus 3, X minus 1. You can cancel X minus 1. So that means that at the least, you'll have a hole at X equals 1. I wouldn't really call it an asymptote. I actually don't think that, well, I mean, this like all simplifies. So like, I don't even think there's a slant asymptote. Yeah, there's like none of these because this simplifies to just a linear X minus 3 with this hole at X equals 1. So this doesn't have the horizontal, vertical, or slant. It's just the hole at 1. It's extraneous if it sets the denominator equal to 0, because then it means it's undefined. So even though if you set this top equal to 0 and factored and solved, you'll get -6 as an option. But since the denominator, when you plug in, will give you 0 in the denominator, you want to say it's extraneous. This, your ideal common denominator, will definitely have 3 and a minus 2. So you're going to multiply this with 3, this with 3, this with a minus 2 over a minus 2. So distribute this. Now get 9a minus 12 equals 3 times 3, which is 9, plus 2a squared minus 4a. Denominator is kind of irrelevant at this point because you have all the fractions with your common denominator. So then just combine like terms. Like I would personally move the 9a over and move the 12 over. It's now is equal to 0, which is a good sign that you're going to be able to factor shortly. So minus 13a. This is plus 21. So now factor this, factors of 42 that add up to -13. It's -6, -7. So factor this with grouping. Factor out 2a, leaving a minus 3. Factor out. Ooh, don't tell me I made a blooper. Sorry, this is 21. Yeah, good eye, 21. Don't need the 42 anymore. So then factor out -7, leaving you a minus 3 again. So cool beans. You're left with 2a minus 7, a minus 3. This all equals 0. You're going to have 2 answers here in this case. You will definitely have 7/2 and 3. So a could be equal to one of those. Your domain for this, it's really coming down to the denominator. You can say it's all real, except that x can equal the roots of this, which is -1 and 4. X-intercepts, just set the top equal to 0 and solve. So that's going to give you an x-intercept at -2. Plug in where x is 0 here, solve. So what's that? 2 over 1 times -4, which is just -1/2. So 0, -1/2. That's it. Your horizontal asymptotes will definitely be there at x equals -1 and x equals 4. Vertical asymptote, in this case, since the bottom is greater than the top, it is just y equals 0. Kind of like 1 over x. I mean, that's a key thing to fall back on. Hope you enjoyed this power hour. Maybe I'll do more. Maybe I won't. I hope you had a good year. And I'm very proud of you. Best of luck on finals. Relax. Don't stress it. Take care. Brush your hair.